Hi, and welcome to Live Streaming Basics. In this presentation, we're going to cover a high-level overview of how live streaming works. This is meant to be a beginner's guide. It will be very general, and it's going to cover the end-to-end processes in general live streaming. This will not get into specific YouTube products. First, let's take a look at the signal flow. This signal flow shows us the flow of the video from source to user. The source video needs to be received by an encoder to be compressed, then sent to a CDN, a content delivery network, for global distribution. From there, it's pulled by a video player and then received by the end user. Let's examine the first step of this flow. How do you get a source feed to an encoder? The content needs to be captured by your AV gear, that's your cameras and mics. From there, it can go directly into an encoder. In the case that your encoder will not be in the same place as your audiovisual equipment, which we'll get into a little bit more later, the video can be transmitted via satellite or fiber to the encoder. For satellite transmission, you'll need to send the source feed to an uplink antenna. Think of a news satellite truck. The antenna will send the feed to a satellite, and then it will be pulled down or downlinked by a receiving antenna at your acquisition point where your encoder is. For fiber transmission, you'll send the source feed through physical fiber optic cable from your source to the acquisition point. Many big convention halls, arenas, and such have fiber run through them. It's great if you have the opportunity to use that, but it is often quite expensive. Let's take a look at some vocabulary when we talk about delivering the feed from your source AV equipment to your encoder. First, we have the term signal transport or signal flow or transmission path. These are some phrases used interchangeably to refer to the path that the video travels from source to destination. So you'll often hear a video producer ask what the signal flow is for an event. In that case, he's wondering, are we using a satellite truck? Are we having the encoder encode the feed directly on site with the camera equipment? What path is that video feed taking? Signal acquisition refers to the method by which the video is received. It's usually a term used when you're using fiber or satellite. So for example, you may hear the phrase, Acme is handling the signal acquisition and encoding. In that example, that means that Acme is receiving the video feed by satellite and then routing it to their encoders at that facility. So a couple of other phrases that you'll hear are uplink and downlink. Uplink and downlink are pretty obvious. They refer to the transmission up to a satellite or down from a satellite up in space. Satellite time and space segment refer to the actual time and node that you're booking on the satellite that's up in space. All of this time is actually reserved in advance. So you have to be very careful about making sure that you're covered on time. If you have an event that's expected to end at noon and you only book satellite time through noon, if your event runs long, you may not have the opportunity to extend your satellite time if somebody else has booked that time already. So be very careful when scheduling that time. Similarly, fiber time is also booked in advance. Fiber optic cable is physical cable that has a data limit to it, so you can only have a certain amount of data traveling through it at any given time. The encoder and the encoding software are often confused. When you reference an encoder, you're talking about the physical device that has the encoding software on it that is being used to compress the data. Your encoder can be anything from your laptop in front of you that has a consumer level product like Flash Media Live Encoder installed on it, to an advanced, sophisticated, dedicated encoding machine that professionals use. And the encoding software is just the software that actually performs the video compression. We always recommend that you have a dedicated computer doing your encoding for you. You never want to have a lot of activity going on one machine, especially when you're using that for a live event. For example, if you're going to be streaming yourself playing a video game, you ideally want to take the source computer that you're playing this video game and use that as your video source to a separate encoding computer. That way, if your video game freezes or stalls up, you're not going to affect your live stream and you'll still be able to message to your users that the event is still happening. You may just have a little delay while you catch up on your game. It's really important not to have a single point of failure. And usually that's the encoder, especially if you overload it with a lot of programs. You want to be very careful to check the CPU load on your computer that you're doing your encoding on. The next step in the path is the encoder to the CDN. Once you get the feed to the encoder where the data is compressed and optimized for the web or mobile playback, it needs to be globally distributed. You want to make sure that you're balancing the load of requests to view the stream. Even for a small event, you don't want 200 users, for example, trying to view the stream directly from your encoder, because odds are it's not built for that. So within the encoding software, you'll designate a server on a CDN, the Content Delivery Network, where you want to send that feed. The CDN ingests the feed at the edge of the internet and distributes it to its servers around the world. This transmission from encoder to CDN happens over the internet. So your encoder needs to be located somewhere with reliable internet connectivity so it can continuously stream the data to the CDN. If there isn't reliable connectivity where your video source is, that's when you need to consider bringing in satellite or fiber transmission. You can use those to transport your video to your encoder at an off-site location where you have reliable connectivity to stream to the CDN. Some vocabulary terms here. We covered CDN, stands for Content Delivery Network. POP is a reference that you'll hear a lot. You'll want to stream to your nearest point of presence, that's what POP stands for, and that's the physical location of your CDN servers. For example, if you have an event that's happening in New York, your nearest servers might be in Atlanta. You'll want to stream to those, not to a set of servers, say, in Taiwan. Your CDN connect info, your ingestion info, or your encoder output info are three common phrases that you hear that mean the same thing. You're talking about where on the CDN you're sending your traffic. So in most cases, your CDN is going to give you the address of a server. That is what connects you to your CDN. Next we have the CDN to the user through the player. The CDN is going to generate a playback URL for the stream you're sending. That playback URL will be plugged into the video player that users use to watch the stream. In many cases, including YouTube's, the player will automatically detect that playback URL from the CDN when you create the event. But if you're building a player from scratch, you need to tell the player what stream on the CDN it's going to be pulling from. When the user connects, the CDN is going to determine the nearest point of presence, that POP, for the optimal playback. So for example, if you are in Houston, you may want to connect to the POP in Atlanta to watch the stream rather than connecting through the POP in Singapore. Obviously there's going to be a lot more delay if you're trying to travel that distance. This way the CDN can distribute the traffic load to ensure the best delivery to the user. Sometimes a CDN will see issues with a local POP. In that case, they're going to automatically reroute traffic to another POP in the area, detouring users around the problem delivery servers. The important vocabulary term here is the playback URL. You'll often hear encoding providers ask for the playback URL from the CDN that you've created. This is the URL that they're going to use to actually watch the stream on the player. The important thing to remember is that you need to account for all of the links in the chain here to trace back any issues that you may have. If the user is having a problem, eliminate user error, then check the player. Make sure that the user is actually connected to the internet. Make sure that the user's CPU load isn't too high. Make sure that they can watch some other stream on the internet. If you've checked with many users in many different locations, then you can probably eliminate the user as the error. Next, you want to check the player. Is the player actually pointed to the correct playback URL? If it is, you want to check the CDN. Is the CDN properly delivering your stream? Many times you'll be able to monitor the stream coming right off of the CDN. If you can see the stream coming right off of the CDN servers, then you can see that the stream is actually getting to that CDN. If it's not getting to the CDN, then you want to check your encoder and your network. If you aren't seeing your stream coming out of your encoder, then it's likely a problem with your encoder. Make sure that your encoder isn't overloaded. Check the CPU. Check your network. Make sure that everything is coming out of your encoder okay. If your encoder looks healthy, but you're still seeing the errors in the stream, check your source. Did somebody kick a cable? Is there a loose audio cable that is causing interference? Did somebody kick a power cable to one of the cameras? These are very common problems, so make sure that everything from source through player are all functioning. Now we're going to get into some vocabulary terms here. The one phrase that you're going to hear a lot is a codec. The codec, depending on who you're talking to, either comes from the phrase compressor, decompressor, or coder, decoder, and it's just the technology that's used to compress the data. Common video codecs are MPEG-2, BP6, H.264. There's lots and lots of different codecs. The YouTube Live Player currently only accepts the H.264 video codec. For audio codecs, some common examples are AAC and MP3. We also get into the domain of wrappers or container formats here. You can think of a container format as just that, a container. For example, Flash, the technology that YouTube prefers, is a container format that utilizes the codecs H.264 for video and AAC for audio. You can swap out a container without changing the actual file type if you need to change the way that the data is being read. One of the most important determinants as to the quality of your stream is the bitrate. The quality of stream is measured in bits per second, and that's the amount of data transferred every second. Most commonly you'll hear kilobits per second or megabits per second. You'll often hear people say megs or K. There's lots of different colloquialisms around that. Keep in mind that each stream has its own bitrate, and you want to account for the total of all of those bitrates if you're doing a multiple bitrate streaming, and the total of any redundancies that you're doing. We always recommend that you stream redundant encoders, so if you have 3 bitrates and 2 encoders running simultaneously, in the example here where you have one 500K, 1 meg, and 1.5 megs, that's 3 megs on one encoder. Double that is 6 megs of outbound traffic. You always want to include a buffer on top of that of about 20% to ensure that you have solid network conditions. You want to make sure then that network is completely dedicated to your stream. You don't want any outside traffic getting onto that network and interfering. Remember, the higher the bitrate, the higher the quality of the stream. But the higher the quality, the more difficult it can be to watch. So consider your audience. The total bit rates you're streaming cannot exceed the amount of available bandwidth. This is very, very important. Often the location where you're filming does not have sufficient bandwidth, and this is where we talk about bringing in satellite trucks or fiber to transmit the feed to an offsite location for compression. Some golden rules: make sure you don't cut it too close. Always leave room for overhead. If you only have a T1, which is 1.5 megs, don't stream a 1 meg and a 500K stream. We recommend leaving about 20% for overhead. Rule number 2, think about who else is on your network. Your office may have an OC3, but if 1,000 people are sharing that network, the bandwidth is quickly used up. Also consider the bandwidth when you're testing versus your live event. If you're doing an event in an office and your test the evening before at 6 o'clock, you may not have anybody else in the office in that network. When you come in the next day to do the event, all of a sudden you have 1,000 people on that network. So you should really always have a dedicated network whenever possible. Always run a speed test. Never trust an IT person who tells you how much the bandwidth is without double checking it. It's really difficult to increase your bandwidth once you're already on site trying to configure an event. Also keep in mind the difference between your inbound bandwidth and your outbound bandwidth. When you're streaming, the outbound bandwidth is what you care about. Lastly, make sure you're on a reliable network. Remember, an interruption in your connectivity equals a broken or dead stream. So don't stream on Wi-Fi, don't stream on wireless cards. Use a wired, dedicated network. A couple of other useful definitions that you'll hear in the industry. A multicam player is a player capable of playing multiple angles for a single event. For example, you can have a football game that may have the director's cut or the line cut, which is perhaps what you would see on television. And then you can have an end zone camera or a sideline camera or a star camera, a quarterback camera that you can choose to flip between. The difficulty here is that each of these camera angles needs to be synced so that if the user switches between these cameras, they're still at the same point in time. You want to make sure that each camera is treated as its own individual event. So for a 3-camera webcast, you would need 3 encoders if you intend for all 3 of those cameras to be a completely different stream. DVR, just like your home DVR, refers to a feature in the player where you can pause and rewind. The CDN is going to capture the bits coming to it and record them in real time so that you can seek backwards and pause in your live event. When configuring the DVR, keep in mind how long you want that DVR window to be. Do you want it to run the full length of the event, or only to show the most recent 10 minutes of the event? You'll also hear the phrase simulive. Simulive is a term used when an event is recorded in advance and then streamed back as if it is live. This is often done if you have, for example, say an award show that is taped ahead of time, but you want it to be streamed only once and not watched as on-demand content. So you're going to record and edit the show, and then you'll play it using a DVR or a tape deck or whatever, and use that video as the source for your encoder. To encode means simply to compress some data for storage or transmission, especially to a lower data rate. To re-encode is to resave a file to the same format after you've done some editing to it. To transcode is to convert to a different format of a similar quality to gain compatibility to another program. For example, you can transcode a Windows media file to a Flash file. This usually involves generational loss, so the more transcoding you do, the worse quality you're going to see. Transmuxing is when you swap out the container or the wrapper file. Testing. It's a big red slide because it's the most valuable thing you can do in preparing for your event. When you're on site doing a live event, the chaos can often get a little overwhelming. And the more prepared that you are, the better off you'll be. Never try and go into any program, no matter what you're using, and start from scratch the day of an event. Some tips we have here for general QC and production are: first, to verify the proper operation of everything that you're using. This includes every camera, every switcher, mixer, receiver, DVR, any source that you're going to be using for your feed, every microphone. Check batteries, check the condition, check everything in a real production scenario well in advance of your event. The last thing you want to do is have batteries die in a microphone in the middle of your live event. Next, you want to verify that everything is routed properly. If you're using a switcher and a mixer for a multi-camera event, make sure that you have everything routed through your mixer properly. You also just want to verify the overall quality of your video. Make sure that you're not seeing any interlacing, any fuzziness, any weird colors. Make sure you white balance. Make sure that everything looks good and sounds good on all of your sources. Next, and often overlooked, is the cropping in your encoder. Many times when you switch between cameras, you'll see a little black border around one camera that you didn't see on another. You can really easily crop this out in most encoding software, but you don't want to be trying to do it in the middle of an event. So check all of your camera sources, all of your video playback sources, your DVRs, your video decks, whatever you're using. Put them through the encoder and make sure all of the cropping looks good before you start. You also want to perform an audio sync test once your encoders are running. You want somebody in front of your camera on a microphone doing a clap test and going through the alphabet or whatever you need to do to make sure that their lips are synced. Lastly, you want to verify the strength and stability of the outbound network, as we discussed. It's very important that your bandwidth needs meet with what you're going to be streaming. Some encoder tips. Make sure you configure your encoder at least 2 hours in advance of the event. This is bare minimum. There's not a lot you can do in 2 hours to fix something if it goes wrong, but it's better than 15 minutes. Start your encoder at least 15 minutes before the event is scheduled to go live. We really prefer 30 minutes to an hour, but you don't want to be hitting start just as someone is going on stage and see that there's a problem. In YouTube, before clicking Start Broadcast, make sure that everything looks good on the video page before you expose it to your audience. You can do this by going to Video Settings and click View on Video Page on the top right. Once you're encoding, make sure you test your backup encoder too, which we always recommend that you use. Stop your primary encoder or just unplug its Ethernet cable and make sure that the player automatically rolls over to the backup stream. Then restart your primary encoder and unplug your backup encoder and make sure that it rolls back to your primary. You should always be taking a local archive of your video as well. Once you've started, open up the file that you're recording to and make sure that the file size is growing. You can just refresh the window a few times and make sure that the size is getting larger. When you're ready to take your show live to the public in YouTube, make sure that you hit Start Broadcast. If you're viewing as an admin logged into your channel, you're going to see a notice up at the top of the page that says this event is not yet live, but you are able to view because you're an admin. If you see that message, you're not live. No one else can see the stream but you. Make sure you hit Start Broadcast if you want anybody else to see your event. Then check your channel and your watch pages and make sure that you're seeing everything properly. If you're streaming from mobile, make sure that you're seeing it on mobile devices. And throughout your event, make sure that you continuously monitor. Things can change at the drop of a hat. Here we reiterate our network tips again because they're very, very important. Again, remember, don't cut it too close. Always leave room for overhead. Remember who else is on your network. Always run a speed test. and make sure you're on a reliable, dedicated network. A few production tips. When it comes to backgrounds, make sure that your background provides contrast with your subject's face, clothing, and hair. Avoid extremes in contrast or color. Don't have anything that's very, very dark next to something that's very, very light. This tends to be hard on codecs. Avoid using extraneous detail in lighting or pattern. You can watch a lot of live events where you see somebody wearing a pinstripe shirt and the little squiggly lines that appear on that pinstripe shirt. That's because the codec is having trouble compressing the data of that detail. Avoid highly saturated colors. Avoid busy backgrounds with a lot of detail in them. And make sure all of your light sources are consistent. Avoid doing an indoor shot with fluorescent lighting next to a window, for example. Here are just a few tips when it comes to wardrobe. Make sure that everybody who's speaking takes their badges off if you're doing a convention, for example. Generally stick with solid colors. As we said, those pinstripes and patterns can be hard on the encoder. Avoid wearing white and light blue because everything will just look white on camera. Make sure that you're contrasting with the background and have your speakers bring alternative wardrobe options, just in case. For ladies, a lot of times it's easier for hair to be pulled back, especially if they have frizzy hair. All of those little detailed hairs can be really hard on the encoder. For jewelry, again, make sure you avoid shiny and detailed surfaces. If you have a subject wearing glasses, just keep your lighting in mind to avoid a glare on the glasses. When it comes to video, lighting really is the single most important determinant of quality, no matter what you're creating. Ensure that you have enough lighting to shoot with zero gain on your camera. Don't mix color temperatures, as we said, and soft light really is easier on encoders if you can help it. When you're shooting, make sure that every motion of the camera is deliberate and making a point. Unnecessary motion adds stress to encoders. Avoid slow pans, dissolves, zooms, anything like that. If you can do a hard cut, do a hard cut. It's a lot easier on your encoder. Avoid handheld camera when you can use a tripod. All of that little shaky movement, again, adds stress to your encoder. And when possible, shoot progressive so you don't have to put a software deinterlace filter on your stream. Some audio tips. If your source is mono, encode as mono. If you try to force a mono source through to an encoder as stereo, this just causes the audio to be heard twice. If there will be Q&A, make sure you have microphone runners available and instruct everyone to wait until they have a microphone before asking their questions. Remember, if they're not mic'd, they can't be heard on the stream. And lastly, make sure all of your speakers leave their cell phones and PDAs and whatnot off stage. You want to avoid hearing that audio interference that we all dread. If you see a problem, you want to make sure that it's not localized to one user or one network. How many users are seeing the problem? Is it just one? That's likely user error. Is it many on one network? That's likely a network issue. If you have a lot of people in one building who are unable to see the stream, they may be maxing out the bandwidth available to that building. If you're seeing many problems on various networks, then it might be a possible source error. So you want to check the health on your encoder. Does the stream look and sound healthy directly on your encoder? If it doesn't, then something going into your encoder is going bad. Remember, garbage in, garbage out. So verify the health of all of the audio and video sources routed to your encoder. If all of the sources are good, check the encoder itself. What's the CPU load? Is the stream healthy on your backup encoder? Be sure to check your archive too. If you're seeing audio or video problems in your local archive file, the problems are being introduced locally. If everything looks good in the encoder, it might be a network error. Run a speed test and a ping test to YouTube if you're using YouTube. If your outbound bandwidth is unstable or inadequate, then you're having network problems. You should contact your local IT support to troubleshoot. If the network is solid and you're able to connect to other external domains, but you're unable to connect to YouTube, then it's a possible CDN error. In that case, we encourage you to reach out to email support. But be prepared to present the results of all of these troubleshooting tests. That's it. Hope you enjoyed the presentation and happy streaming.